Alyssa Goodman, and the name of the course is The Art of Numbers. Well, this course is about how we can display quantitative information in ways that the human brain is better at understanding than just tables of numbers or long formulas. And those ways usually look like pictures, and we usually call them things like maps and charts and graphs. You know, there are these long papers with loads of equations and lots of words, and everybody looks at the pictures first to try to understand the central concept that somebody's trying to convey. And the same thing is true when you look at a newspaper article and you pick it up and you look for the graph or you look for the map, and then you try to understand what it is that they're trying to show you in the map or the graph, and then you read the article, and then it all makes much more sense. It's been shown in many studies of human cognition that not all, but almost all people understand mathematical concepts and quantitative data better from visual displays. So when I first started teaching this course in 2002, technology for online display of data graphics was really still not that common. And now it's only 8 years later, yet this technology is completely common. And so each year I get to revise the course into a completely new form. And this year, in addition to having students share examples of their favorite graphics online through interesting social networking technologies, we are also going to have the students use and help develop a new application that will run on the iPhone and other mobile devices that will not only tell you about the weather, but it'll actually explain why you should be concerned about the uncertainty in weather forecasts. The application will look something like that, and it's based on historical data like what you see here, but that distribution tells you in the past how good the weather people were at predicting the weather under the same circumstances where the same temperature was predicted. And so we get to talk about things like uncertainty and computer modeling in the context of things that students encounter in their everyday life, like weather forecasts. But then that lets you understand things like, well, how sure are we about financial forecasts or about climate change or about epidemiology? And so this actually is a project that Harvard students are being brought into right at the beginning, and it's part of a larger effort in collaboration with WGBH, where we're talking about the use of computer simulations in everyday life. We like to choose examples in the course from many different fields, and they do change from year to year. In the political arena, we love to look at alternative displays of what people normally see, usually in print. So for example, there's the famous map where you see the red states and the blue states. And a lot of people have sometimes seen that modified, where you take the red and the blue and you mix them together to make just the right shade of purple, depending on how many Republicans and Democrats there are in a state. But few people have ever seen that done not only at the county level, but then also adding in the information about how many people, what the population is in each county. And then you get the real picture where it's true that lots of the country looks red, but all the big spikes are blue. And it's so much easier to explain that than to explain a weighting function in election math. And this year we plan to go a little bit farther, and we're going to work in collaboration with the people over in the Many Eyes effort at IBM, which is a social networking site for data graphics, to try to let students categorize what they think is important about particular data graphics and what they think is good and what they think is bad. And we might actually get enough information to build up a big database where we can almost start to develop an empirical theory of graphics based on just one instance of this course. And so the students will actually become contributors in this effort, this collaborative effort with friends at IBM and at Harvard, trying to figure out if we really can make an empirical theory of what works and what doesn't. So why should you take this class? Well, I think that it has a very interesting combination of a theoretical approach to why particular kinds of data displays work the way they do, but then a very practical aspect about how you can use different kinds of data displays in your own work and to understand the world around you in the future.